So we have a slight problem. As we saw, the future will be that we're all transcoding our code into C++, and it'll be super fast and super scalable out the box. But sadly, that's got bugs, and so we're not quite there yet. So we need an alternative. And thankfully, that alternative, for us at least, has been Docker. And so tonight, I just want to kind of highlight how we're using Docker, how we're deploying our applications, and how we're using that to scale Node.js. So my name is Ben Hall. I'm the founder of a software development studio called Ocelot Uproar, and we do training sessions and training courses with companies. We help them build products, and we also build products internally. So we're currently working on two. One is Katacoda, which is an online learning environment for developers, and we help teach topics like containers and Docker and infrastructure-related technologies. The other is Brownbag, which is we want it to be like Netflix, but for developers. And tonight, what I want to talk about is some of the problems which we found scaling Docker, scaling Node, how we're using Docker to deploy, how we're scaling on a single machine, and then how we're scaling across an entire cluster. So this all came about with our product called Katacoda. And what we do is provide online sandbox environments where people can play and they can learn new environments and they can get comfortable with technologies without the fear. So we've got things like Node.js, but we also have things like Docker, where you get a sandbox Docker daemon running in your browser with a step-by-step tutorial, teaching you how you can launch containers, how you can build things, and everything's just ready, waiting for you to get launched. No configuration, no downloads. And while I'd like to say that we've followed the Node approach and everything is asynchronous and it's all non-blocking, there are certain bits in the application which we found to be a little bit CPU heavy. And so there's things like array filtering, some sorting, some processing, but nothing major. And so we ran a load test on one of our environments, and it was like 60,000 per server per day, what it could handle, which is okay. But we did some rough calculations, and it should be a lot more than that. And so we got it up to 1,112 without doing any code changes and without making any modifications, just on how we actually deploy our Node applications. And so, why is Node a problem in the first place? And this is all down to the lovely event loop. As I'm sure we're all aware, Node is single-threaded. So anything which happens, which blocks that thread, is problematic for everything else happening on that system. For example, if we have this nice, lovely loop going, and instead of it instead of being idle and continuing to poll and continuing to go round, if something blocks it, say you're doing a synchronous call, then nothing else in that loop can happen. Nothing else can execute, and as such, your application slows down. And this is what we assumed we were seeing in terms of our performance and it not being quite as ideal as what we wanted. And so the problem is add more threads, and then it will be like, problem solved. So this is what we tried to do. And the question is this already a solved problem? Is there anything which we actually had to do? So in recent versions of Node, it's got cluster support. And so what you can say is, if you're the master, then for as many CPUs as you've got, spin up sub-processes, and if you're not the master, then actually do your job. And what this kind of generates as a result is that we get one web server and it spins up 4 different sub-processes, and they can all manage the workload, and you can spread and manage your calculation and your computation across these 4 different processes. The problem with this is, I don't really want Node to be responsible for this management. I don't want my Node application to be dealing with it, because it's just a little bit out of scope. It's not its responsibility. And so I just found it weird. And so there's alternatives. So we've got the strong loop, and they've got a commercial offering if we wanted to use that. And we've got PM2, which is Process Manager 2, which is open source, but comes with a very restrictive license. And so again, that was like, I don't really want to be playing in this game. I want to do it differently. So thankfully, we were using Docker. So what is Docker? So if you think of containers and software containers as the way the real world works. So every day, millions of items are sent all around. So we've got cars, we've got t-shirts, we've got beer, all in these huge metal boxes. The metal boxes need to be a certain size, they need to be a certain shape, and most importantly, they just need the hooks on every corner. It's these hooks on every corner which allows them to be connected and create this very strong, coherent unit. And this is the same for software containers. Software container has everything which you need embedded into the image so that when you run it, it's got everything such as your version of Node, it's got all your NPM modules, it's got all your source code. So when it launches, it's ready and it's just set up and ready to run. In order to build this container, it's very straightforward. We've got a Docker file which describes the instructions and how you want your application to be deployed. So you start off with a particular version of Node, for example, 0.10 if you're really slow and behind like me. You then list, like makefile, copy your source code into that particular directory, user source app, run npm install, and then you can launch npm start, which brings up the process, build it, run it. Great, we've got our Node application deployed into a container and Dockerized, and it's lovely. A couple of things wrong with this, which we found in terms of performance and scaling. The order is very important. Order matters. So what we do is copy the package JSON first, then run npm install, and then copy the rest of the source code. The reason for this is that Docker's got built-in caching, and so Docker will know that if nothing's changed, it won't rerun the same command. And so in here, if package JSON hasn't changed, it won't bother to rerun npm install. It will just take what it did and what it had last time, and as such, everything becomes a lot quicker, and we can deploy a lot more rapidly, which is good. In order to make this a little bit more manageable, we use the onBuild tag. And so this simply says that when this image is being used as a base image, run these commands in this particular order. And so we can be very confident that everything's being built and everything's being run in the way which we want. And so at the bottom, we've just got our Docker file, which simply says from node on build and just a port, and that's it. That's everything you need. Second to this, the size also matters. So what we're starting to do for some of our applications is use Alpine as our base image. So Alpine is a very slimline, cut-down version of a Linux distro, and it doesn't include all of the additional fluff which you may not need if you're deploying an application. And so for us, our very simple example used to be 700 meg, and all it did was connect to Redis. And it's like, why do I need to deploy a 700 meg file just connect Node to Redis? Using Alpine, 35 meg. It feels a lot more realistic and a lot more manageable. And so now we build our application and we run it using this, and previously we bound it to port 80. And we also use the restart flag so that if Node happens to crash for whatever particular reason, it would automatically restart itself, and we've got this process management built in out of the box thanks to Docker. So we now want to scale it. And we now want to scale this one process which is bound to port 80. So that's problematic. So let's introduce a proxy. Proxy solves all of the problems, and we can use that to manage everything. So attempt to one looks something like this. We had Nginx. This was bound to port 80. This would link to 4 different containers running Node, and then we'd just load balance across the 4. And this would be very nice because instantly out the box, we had 4 different processes. They could all handle their own requests, and then Nginx would manage which one should actually be processing at that particular point. If one went down, then it would manage it, or take it out the load balancer, and the website would continue to work. The problem is that if we wanted to add a 5th, we'd have to take down the entire application, and then that would be problematic, and we'd lose everything, and it would just cause all kinds of problems. But thankfully with Docker, we have Docker events. So every time a container is launched or stopped, it will raise an event on its API, and then things can listen to this event and take actions upon it. So this is where Nginx proxy comes in. So again, we bind this to port 80, just as we did before, but this time we also pass in a hook to the Docker socket file. This gives us access to the API and the daemon running on the machine and running the container itself. Now when we launch a new container, for example, our website, we define a new environment variable called virtual host. The virtual host is just the domain name or the routing which we gave it, and so how do you access that container itself? In this case, www.catchcoder.com. And Nginx proxy will see that this has been launched, and it will automatically update the configuration file and add it into the particular config and make all the adjustments it needs, so the right IP address, the right port, give it some weighting. And it does this in the covers dynamically based on the events, what's happening inside the Docker daemon. And so if we want to load balance, we simply launch 2 different containers, make sure that the virtual host is the same, and then Nginx proxy will do the right thing. It will merge them together, it'll load balance instantly, and with some tweaks you can change the weighting, you can change its load balancing, whether you want it round robin or leaf connected or IP hash, and it just all works magically and out the box very nicely. And if you're using things like Docker Compose, which makes it easier to launch containers and run Docker, then you simply just issue the command scale web5, and it will bring up 5 containers. They will all automatically register themselves, all of the configuration will update, and then you have it load balanced across 5, which is very nice. Apart from a few different things which we kind of got hit by. First off, Socket.io loves to store everything in memory, which is really frustrating. And so we used IP hash so that when you go to one server, you always go to the same server. And so that's how it can keep track of your user session. And global state, which if you're using global state, you're kind of asking for trouble anyway. But this kind of really highlighted it for us. So that allows us to scale one machine. And so we've now got 4, 5, 6 different node processors, depending on our CPUs. And so we can scale everything happily. But what about scaling the cluster itself? And so this is where you need a software-defined network when you're running with Docker. So when 2 containers on 2 different hosts want to talk to each other, unless you have opened up the port and you're using it the old-fashioned way, then you need some way for them to talk to each other. And this, in this example, happens to be Weave. You launch Weave, Weave creates a software-defined network. When one container wants to talk to the other, Weave will wrap up the network packet, send it over the wire, replay it on the other side, and then containers can magically talk to each other across 2 hosts. For example, on host 1, we can run Weave launch, we can run a web server. On the second host, we connect it to the first hosts, and then all the commands are just transparent. They can talk across machines, and now we can start actually being a little bit more redundant and scaling across multiple different environments. And so what we can do is if we start 3 different HTTP servers, Weave will detect this. It will connect them all up using Weave DNS. And so when you try and access one of these containers, it will give you a different IP at random every single time. And so now you've got load balancing at your process level by using Nginx proxy, and you've got load balancing at the machine level by using Weave, which is very nice. And it just kind of, for us at least, we got the 50% or near 50% performance improvement by just simply changing our configuration file. And instead of binding to port 80, we just bound to Nginx proxy, and then that managed all of the processes for us. But the one thing which we did find was that the code performance also matters. So while you can run multiple processes and that will help manage that CPU, if your code is not very performant, it's going to hurt. So thankfully, we have this guy. And we have some of the awesome talks which he's done, for example, the one last month. And so he can actually help you make your code more performant. And then when you combine the 2, you can have a very scalable, very high performance node application, which kind of, for us at least, worked out the box without changing anything. And so with that in mind, we need to be cracking on. So for us, we had this problem. We wanted to get more performance out of our box. We found there was a bottleneck into some of our code. The answer was to use Docker and to bring up multiple containers and load balance across all of them. And Nginx proxy meant that we don't have to write any configuration. It's all done the auto discovery, it's all dynamic, and everything loads. And then Weave DNS will allow you to do this across multiple different machines. Katacoda is hiring, like everyone else. We believe we're building the future for how developers learn. And we are all remote, and we're looking for scenario authors and content authors. So if there's something which you want to write, then please do get in touch. We're flexible on time, language, programming language, aspects, everything like that. And we're also looking for people focused on working more in the community, so developer relation type people. And with that, I'd like to thank you very much for your time. And if anyone has any questions, then please do let me know. Thank you.
Okay. Does anyone have any questions?
Yeah.
Hi. How do you manage your containers? How do you deploy new code, scale up and down, etc., without just doing everything on the shell?
Yeah, I kind of just do everything on the shell. So mainly that works because we use Docker Compose, and so we can take the hit of it being just SSHing into the box and running everything. If I was going to do it a little bit more professionally, then I'd probably go to Docker Swarm and use that as a centralized hub. If I wanted it to be really professional, then I'd probably use Kubernetes and have Kubernetes managing all of that networking stack for us. No, just because we're at a particular size and we don't need the over added complexity that will introduce. So we SSH in, we pull down the latest image which has been built on a remote server, we do Docker Compose up, and then that just brings up a new environment, and then everything automatically re-registers itself where it needs to.
Do you have any monitoring?
Yeah, so we've got monitoring through health endpoints. So we've got a particular URL, and that pings, and we've got Uptime Robot, which pings everything, and when that goes down, we get notified, and then that's just got a whole heap of logging attached to it, so we know which particular service and which particular code component kind of was unhappy at that particular point. And then we use Docker for the process management, so that will keep Node alive and restart itself automatically, so we can be confident that if it's just a hiccup, then stuff will restart itself.
Hello. Why did you use Nginx proxy as well as Weave? Why not just use Weave for everything?
Yes, that's a good question. So why the proxy and Weave itself? For me, one, it was a natural progression. We started with one and we just naturally added and continued to increase. Also, by having Nginx proxy, we can be a little bit more targeted about which processes are running on which machine, how are they talking, which ones are up and which ones are down. And we have a little bit more flexibility about just managing each box separately than manage them as one big cluster.
Like all your services on one box, like each individual host is a separate service.
Yeah, pretty much. And so when we want to add a new host for scaling, we just literally clone it and replicate it, and then that brings up the other thing. And so it made it just a lot more consistent. And so it was manageability. But it completely works, and you could do that if you wanted. The one bit which I'm not sure how it works is like IP hashing. And so being very fixed about your weighting between different processes and different services and stuff like that. But Weave is cool. It will have a feature somewhere.
Cool. Does anyone have any more questions? All right, so let's give Ben a very big round of applause. Oh, no. Oh, you'll have to do it in the pub.